on the body. So force is push or pull on the body. Okay. So force is said to be mass and what? Acceleration. Right. That's the basic definition of mass. Right. So like Newton, he's the one that did a very nice work on force. He said something about force. He said that the body will continue in any state of rest or random motion in a straight line except acted upon by an external force. Right? So, except an external force acts on it, the body will remain in this state of rest. But like this dust that was on that table until I pick it up, right? An external force have acted on it, right? I have to go and pick it up. Maybe a car like moving, and then you see maybe a kind of another car on the road, right? There's another car on the road, and that car is just there. It's not in motion, right? And then it's a moving car. What that moving car, if it hits that car, there's going to be an impact on the car, right? So after that impact, whether the car moves or not depends on the weight of that impact, right? How the impact will have to overcome the force now that the impact have to be able to overcome the weight of that body. So once it's able to overcome the weight of that body, the body starts to move, right? Good. So it remains in this state of rest. It doesn't move until acted upon by what? An external force. That is a push. Something pushed it for it to move. Okay. So we look at this is a body, for instance. This is a body, right? We just here a 5 kg body, for instance. So this body will still remain like this, right? Except acted upon by an external force. But there's a force acting on this body, and that force is the weight of the body. So the weight is acting downward. The weight is what is keeping it in that state. So if your body is staying there, it's because of the weight of the body. That is what is keeping it there. So, but if an external force acts on it, right, it tends to what? Push it, right, in a different direction. It could also pull it up, right? An external force will pull this guy up. So, remember also, he said something that actions and reactions are equal and what? Opposite. So, if there's a downward force, there will be a normal force acting on it upward, right? The normal force acts what? Upward, while the weight acts what? Downward. So the normal force is equal to what? The weight of the body. So that is when equilibrium, right, is attained, right? So the upward force must be able to balance the what? Downward force. The upward force is the same thing as the what? Weight of the body. So how do we get the weight of the body? Remember, weight is different from mass, basically because weight is what? Mass times what? Gravity. So gravity acts on the body and it gives that body the weight, right? So the mass of the body, the quantity of matter contained in that body. So the quantity of matter contained in this body, we have 5 kg, right? So we have 5 times gravity. Gravity is basically what? Acceleration to gravity is 9.8, approximately 9.8, right? So basically it's 9.8 something. But we usually use 9.8 or 10 in the basics, right? If you go further, I think okay, so we have 9.8 times what? 5. That gives us 49 Newton. Okay, so the downward force acting on this body is 49 Newton. It basically means that the upward force also is what? 49 Newton. So the normal force Fn is equal to 8 is equal to what? 49 Newton. Okay, so that's basically what it is. Hope that's clear. Okay, let's look at something else. Let's look at it. So you can increase the normal force. The normal force can be increased, right? By doing what? By exerting a downward force. You can increase the upward force by exerting a what? A downward force. Let's say this is still This same body, remember, is weight force acting on it, 5 kg. And then I exert a downward force on it, right? A downward force of, let's say 30 Newton. 30 Newton. I am pressing it down, right? I'm pressing it down by what? 30 Newton. So what's going to happen? What's going to happen? The normal force will remain the same. Remember, the normal force is the upward force acting on it, isn't it? So there's a downward force of what? This is 30 Newton, and the weight is also what? The weight is mg, which is 5 times 9.8. So the weight is 49 Newton. I would say that actions and reactions are equal and opposite, right? So there's an upward force of what? How many? What will the upward force be now to balance, to make sure that both the upward and downward are the same? So the downward is 30 plus this 49, that means there's a total weight of what? 39, 30 plus 49, upward force, let's call it downward force, sorry. Downward force. Thirty plus 49, which gives us what? 79 Newton, right? So there's 79 Newton acting downward. So how many Newton will be acting upward to make sure everything is balanced? So we said that what will be acting upward will be what? So the normal force will be equal to what? 79 Newton. So that's the upward force. Upward force. Upward force. So the downward force will be what? The upward force will be 79 Newton to balance the what? Upward force acting on the body. Okay. What if I increase the upward force? What do you think is going to happen? If I increase the upward force, what will happen? What will happen to the downward force acting on the body? If I increase the upward force, what will happen? Let's say same body, we have downward force of what? Weight. Here is 5 kg, right? So we have mg, which is equal to 49 Newton, right? Acting downward. Then I now input another force. I include a force, upward force of let's say upward force of 20 Newton. It's an upward force of 20 Newton. So I want force to be acting. The normal force is going to be what now? Normal force will be basically what now? So the total downward force we have in. So can you do that to make it easier? Downward force we have it as 49 Newton. And then upward force we just have 20 Newton alone acting upward. So the normal force is going to be what? 49 minus 20. And that will give us 49 minus 20 will give us this 9. 4 minus 2 is 2, 29 Newton. So 29 Newton will now be the value of the what? Normal force. The normal force will be what? 29 Newton. I mean, total upward force now becomes 29 plus what? 20. And that will give us what? 49. So upward force and downward force becomes what? The same. Still attains equilibrium. Okay. So let's do something else. Let's try to solve one problem. Let's solve one problem. Alright, so we have a rope is used to lift a 50 kg box. A rope is used to lift a 50 kg box with an upward acceleration of 2.3 meters per second squared. What is the tension in the rope, right? So tension basically is when you stress something, right? There is actually tension. Tension is due to what? Pull, right? While compression is due to what? Push. So when you squeeze, you're pushing it, you're squeezing it, right? That is what compression. But when we talk about tension, tension is basically what pulled on a body. So when you're pulling a body, there's tension that is there's tension force acting on the rope. Okay, let's do something really quick. So we are drawing a diagram, a free body diagram, right? We have this at 50 kb, and then we have the force of what? The rope is used to lift a 50 kg box with an upward acceleration of 2.3 meter per second squared. What is the tension on the rope? Now, pulling it upward means that basically the force exerted is what? An upward force, a vertical force. And for vertical forces, we said is y, right? Upward, downward forces is what? Y. But when we have left, right forces, it's called that horizontal forces is x. Okay, so Fy will be equal to MA1. Alright, so now you have to find tension on the what? On the rope. I will say that upward force is equal to what? Downward force. So the downward force will be what? The weight, which is equal to mg, right? So 50 times 9.8. And that will give us what? 50 times 9.8 will give us 490, I think. Okay? 50 times 9.8 to give us 490. Okay. 490 Newton. So that means the downward force acting on that body is what? 490 Newton. Okay, so what will be the upward force? The upward force. So the upward force acting on the body is going to be what? Remember we said that the upward force is equal to what? The downward force. Basically, if this body is on its own, and then we have this guy at the upward force, at the downward force, then it should be equal to what? The upward force. So the downward force should be equal to the upward force. But now I want to find the tension on the rope. The tension on the rope. For that body to be able to be lifted up, for this body to be able to be lifted up, we said that that means the weight of the body is less than the what? Tension. The weight of the body is less than the what? Is less than the upward force, right? It's less than the tension force. Basically, for that body to be able to lift the ground, the weight force must be what? Less than, right? Less than, I mean, the weight must be what? Less than the what? Tension. And the tension must be what? Greater than the what? Weight. The tension must be what? Greater than the what? Weight force. Okay, so how do we get the tension in that particular body? So we have the force will be equal to M, that tension minus what? Weight. Tension minus weight. So the force will be equal to, the upward force is equal to tension minus weight. Basically, I believe you know why we have the upward force equals tension minus weight. The upward one is tension minus weight, basically because the body now has to get off the ground, right? That's why now this upward force, remember, we're going to have, I have that the tension is going to be the upward force plus the weight. Tension will be what? Upward force plus the weight. That's not going to be the tension. But now the upward force, remember, is equal to what? The downward force. Right? Good. So we are going to have something here. We have M AY equal to tension minus what? MG. So the tension now will be equal to what? M AY plus mg. So we have a tension equal to M AY plus what? G. So tension will be equal to M is what the mass of the body is 50, right? And then acceleration in the upward direction equals 2.3 plus 9.8. So this is going to be equal to what? So we have 2.3 times 2.3 times plus 9.8. That's 12.1. 12.1 times 50. So we have 50 times 12.1, which is equal to what? 605. 605 Newton. So 605 Newton becomes what? The tension on that particular what? Rope. Tension on this rope. Tension on this rope. Okay? So that's basically how to find the tension on the rope using this basic concept, right? So that basic concept. So the upward force is Fy, right? And we have the downward force as well. So the upward force, we said that the weight is equal to what? Mg, right? The weight is equal to mg, mass times what? Gravity. So that's how we get that answer. Alright, if you have more questions to solve, please stay tuned for more. Subscribe, like,